Hello and welcome to today's algebra lesson. We're going to start talking about solving systems of equations. Now, in previous work, we would take an equation such as the one we see on the bottom here. Y equals 4/3 times x minus 1. And I would give you something like, I would say, is this a solution? And I would have to give you a pair of points, an x and a y. So I'd say, let's say x equals 6, y equals 2. And you would check to see what you would do is then you would do, okay, does 2 equal, and you're kind of checking to see if this is true here, 4/3 times 6 minus 1. Well, when I do 6 divided by 3, I get 2. 2 times 4 is 8. This will be 8 minus 1. This is 7. Is 2 equal to 7? No. So this is not a solution. Now, if you found something that was a solution, you just had to check this one thing. So I'm going to ask you the same question, only I'm going to ask you about two equations at the same time. Now, once you find that the point isn't a solution to one of them, then you're done. You have to solve a system. The point you're given would have to make both equations true. Let me pick one where that does work. So let's try, is the point 3, 3 a solution? So we're asking this question. To the system. That means it has to make more than one equation true. A system is more than one equation taken together to solve a problem. So in equation 1, we have x equals 3. I substitute the x is 3 for that. Does 3 equal 3? Yes. But I'm not done. I can't say yes yet because I also have to plug in the 3 for y in this equation. Is that equal 4/3 and x is 3 minus 1? Is this true? And 4 times 3 divided by 3 is 4. 4 minus 1 is 3. 3 does equal 3. Yes. So the answer is yes. This is a solution because it makes both this equation and this equation true. So that comes up at the beginning of the unit. Just what do we mean by a solution? It has to make both equations true now. So it's a little more constraining than just making one of them true. Because there are other points. For instance, if I chose the point x is 6, y is 7, it would make this bottom equation true, but 6 for x does not equal 3, so it wouldn't make that top one true. So there are points that will make one equation true, but not the other. When you're solving a system, you want to make sure the point makes both equations true. All right, that's the first thing I wanted to talk about. Then I wanted to talk about how do we find, what if somebody didn't just magically give me this point 3/3? And I didn't know that that's what made it true. How can I find it by graphing? We're not going to do a lot with this, but I want you to understand what finding a system of equations means to a graph. So let's erase everything here and start over. All right, this time I'm going to graph. I'm going to graph x equals 3. X equals 3 goes through the x-axis at 3 and doesn't touch the y-axis. So I get a line right here. And it's not that easy to draw a line. I'm wondering if there's a way I can have this choose to draw lines instead of just, no, I guess not. But I will graph the other equation in a different color. Let me use a green color. Y equals 4/3 x minus 1. Now, if I want to graph this, there's a couple ways I can do it. One way is I can recognize the y-intercept as a -1. So I know that's a point on my graph. Since this is solved for y, I can use that. Then I can go up 4, 1, 2, 3, 4, and over 3, 1, 2, 3. And oh, what do you know? I see that point. Or I could pick some values for x. I could pick x's. It's nice to pick multiples of 3. So I could pick x is 6, and I get y is 7, but you can already see x is 6 is where I could pick x is -3, and I would get y is -5 if I did that, and you can convince yourself of that. If I use -3, that 4 times negative 3 divided by 3 will give me a negative 4. So I'll get negative 5. So if x is negative 3, y is negative 5, that is a point on this line. I'm just trying to graph this second line here. Now, oh, I don't know that that's going to help me. I thought that might help me. I draw this line, and I can already see that this point of intersection, the intersection, is the point that solves both equations. That makes the point that lies on both lines is a point that makes both equations true. This green line basically contains all the points that make the second equation true. The red line contains all the points that make the first equation true. Where the point is the same is where both equations are true. Okay, so that's what I wanted you to understand about systems. First of all, how do we check if a point is a solution to a system? You have to check it in every equation. And second of all, on a graph, how do I know I have a solution? How do I find a solution? Now, if your lines were parallel, if instead of x equals 1, I had my x equals 3, sorry, I had my equation was y equals 4/3 x plus 1. Now that graph would be here. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. See how I did that? You can go backwards there. I'd get that line, and then x equals 4, y equals 4/3 x minus 1. Let me do that in a different color. And if this were my system instead of the x minus 3 over here, I would get graphs that look like this. And that goes up to 3, 3. We figured that out before. 1, 2, 3. And what you see is they're parallel. And they're parallel because the slopes are the same. You can recognize that. So when you have a linear system and the slopes are the same, there is no solution because there's no intersection. And whether you're solving this by graphing or by looking at these, look, you've got 4/3 and 4/3, and you've got these are different. If these numbers were the same, if they were the same equation, you'd have infinite solutions. So there is no solution to this system. There is no point that the two lines have in common. So that is about what you need for the beginning of this unit. So take a look at this, email me your questions, and thank you for watching.